Hello and good day, pre-algebra. We are looking at PO4, which is greatest common factor. This is actually your homework for today. I'm not going to check it in because you have more tonight. We're going to go over a few of them. Make sure you're doing the process correctly, and it'll give you a chance to kind of review the ones you should have done for today to make any corrections, and then some word problems. Then it'll all be due tomorrow. So 24 and 84. Raise your hand if you did the listing method, which is where you just kind of go through and list factor pairs of each room here. Okay? Raise your hand if you did the listing method. Right? Nothing to be ashamed of. It's just fine. Raise your hand if you did the, I don't know what to call it, the grid method. The box method, box grid. That's right. I got to calibrate this quick. Hold on. This is going to be a boring part of the video. I got to calibrate. Okay. 3, 2, 1, you are quiet. So either way you did it, you should still get the same answer. So if you're finding that you're getting a lot of these wrong as we go over them, maybe switch it up. Try something else, right? If at first you don't succeed, try again, but sometimes try doing it a different way. So 24 and 84, let's use the box method here, the grid method. And what that required us to do was to kind of make a table. And what went over in that top left corner there? What went in that top left corner? Camille? It could be 2, right? It's any number that goes into both 24 and 84. So it could have been 2, could be 4, okay? Could be something else, right? But we'll put a 2 there. And then what goes in our next row would be 24 divided by 2 gives us 12. 84 divided by 2 gives us 42. We are slowly factoring numbers out is what we're doing here. And what that's going to allow us to find eventually is that greatest common factor. Question?
No, he's just talking to me.
You are not innocent, sir. Okay?
I was watching you.
Cade.
3.
Take out a 3 of both 12 and 42. You could have taken out a 2 a second time. So if yours doesn't look exactly like this does, that's okay. You should look at the same answer, right? So if things don't look the same, don't fret yet. There's still time here. But 12 divided by 3 is 4. 42 divided by 3 is 14. And then what can we take out, John? Sure. What can we take out, Lexi? 2. Okay. 4 divided by 2 is 2. 14 divided by 2 is 7. And how do I know that I'm done with my red numbers down the side here? How do I know I'm done? Mattis? Right, there's nothing else that can go into 2 and 7 evenly. Okay? And the point of taking these numbers out as we go is that we eventually get numbers small enough where it's pretty easy to tell that. Pretty easy to tell there's no number that goes into both 2 and 7 evenly. How do I get my answer? What is the greatest common factor of 24 and 84? How do we put this all together now, Quentin?
Multiply
2 times 3 times 2, which gives us 12 as a greatest common factor. Someone tell me why it doesn't matter how you pull these numbers out. Like if you did 2, 2, and 3, or 3, 2, and 2, or even 6 and 2, why does that not matter that it has to be in this exact order? Cade? When what? When you're multiplying. Okay? It wouldn't make a difference. We'd still end up with 12. So that was the gist of it. I think I actually remember doing this in class together now. This one. Okay? But looking at then over at 15 and 49, what did you find when working with 15 and 49 and trying to find that greatest common factor? Haley? Yeah. And maybe that's pretty easy to see with that listing method. If you list the factors of 49, you really only have 1 in 49 and 7 in 7. Okay? Then with 15, you've got 1 in 15 and 3 in 5. That's it. Right? The greatest common factor ends up being 1. So it's not that there necessarily isn't one. You could say that there isn't one, but it's because it is 1. Okay, 1's the largest number that goes into both 15 and 49. Okay, so 18 and 42, your answer should be 6 as the greatest common factor. 45 and 150, your answer should be 15 as the greatest common factor. Okay. Anybody get those wrong and not sure how? You want to see it done? Griffin?
I have a question.
Yeah.
Number one. What if you did 4 times 2 instead of 2 times 2 times 2?
Still get 12. Yep. That's the beauty of this, right? However your brain thinks about it, whatever it sees first, as long as you're doing your math correctly, it's going to work out in the end. The order doesn't really make a difference. Anybody want to see it done for 18 and 42 and 45 and 150? Okay. All right. So then the rest of the page, which was also homework, I'm going to leave that. We're not going to correct that today. We'll go over it tomorrow. So if you didn't finish it, you kind of get a freebie in that you have an extra day to do it. But if you got those upper ones wrong, really take a second look at this section here. And we will have work time today, so I should have enough time to walk around and help folks also. Then the second page, the third page of the objective, second page of homework, is word problems. Okay? And word problems are very, very important with the greatest common factor because it's when you're going to actually run into it. You know, very few times in life will you actually be told to find the greatest common factor of 24 and 84. No, it'll be a situation where you are creating prize bags to give to guests at a party. You have 18 kazoos, 45 fake tattoos, and 36 stickers with famous mathematicians on them. What is the greatest number of identical prize bags you can make using all the items? Why would it be important here to want to make identical prize bags for a birthday party? Camille?
Well, if they weren't like identical, then kids would get really mad.
Yeah, what if nobody got any stickers of famous mathematicians? They'd be really upset. You don't want people crying at your party, right? You want to make sure that everyone gets the same thing. Yeah. Oh, so the globe dude means it's like a real world situation. Like when you'll use this out in the real world, you know? Yeah. Okay. The pencil is Mr. Happy Pencil. That's where you get to do the homework. That's like this is also homework here, but it's not just, you know, it's putting into a real world context. Yeah. Yes. We'll talk about that later. Yeah, there was a day when I got locked out of my YouTube channel because for some reason the settings were changed to say I was under 18. I think whoever suggested that, you were actually right. Yeah, whoever it was. But anyway, it's been fixed. It's been since posted, so it's up there now if you want to watch it. Okay. Anyway, how are we going to go about solving this? Okay. The phrase that I underlined is actually how you know you'll be using greatest common factor. Whenever you see something asking for the greatest number and identical and using all the items, those are your key phrases that tells you it's going to be greatest common factor. Okay, so when I find the greatest common factor of 18, 45, and 36, let's do this one together here. I'm going to use the grid method. What number is going up in the top left corner here? Lexi, 9? Whoops, I forgot a mark here. Okay, so 9 goes here. 18 divided by 9 is 2. 45 divided by 9 is 5. 36 divided by 9 is 4. Do I need to go any further? No, there's no number that goes into 2, 5, and 4 evenly. So it turns out that the greatest common factor is 9. Okay? Is that the answer to the question? No, it's not. The question is, how many fake tattoos will be in each bag? So the trick with real world word problems like this is you need to know, what does my answer actually represent? Liam, what does that 9 represent?
The face tattoos.
It does not. The greatest common factor of these items is Cade?
Wait, what was the question again?
What does that 9 represent? It's not the answer to the actual question, which is how many fake tattoos will be in each bag. Sorry? I want to know what the 9 represents. How do I know that's not my actual answer? How do I know there's more to do here? What does the 9 represent? You're saying things that are right, but they're not the right answers to my question. What does the 9 represent, Tony? Which represents what? Lexi? The number of bags you can make. Okay? It's important to understand what these numbers mean. The greatest common factor here represents the number of bags you can make. So if you can make 9 bags, and you wanted to, and I want to know how many fake tattoos will be in each bag, Cade was saying, well, you take that 45 and you divide by 9, and that's where he got the answer of 5. Right? So many times, kids will get the 9 and they'll stop. They'll say, I found the greatest common factor, that's it. But there's a little extra step. Okay? That represents how many bags can be made, not number of fake tattoos. So, as you read through these here, the next one, you're in charge of creating identical first aid kits for a camp. You have 40 rolls of tape, 24 ice packs, 80 bandages, and 16 body wraps. My goodness. What is the greatest number of identical kits you can make using all the items? Here's our phrase, right? Identical kits, greatest number, all the items. Those are your phrases that clue you in to greatest common factor. And it says how many of each item will be in a kit. So when you go through this and you solve for the greatest common factor, whatever that is, what is that going to represent? Don't tell me what it is, but what is it going to represent? In this case, with all these kits, you're making kits using all these items. What is your greatest common factor going to represent? Yeah? How many kits? Just like this one was how many bags, right? Your greatest common factor is going to be the number of kits, which is not your final answer, because you've got to tell me how many of each item is going to be in each kit. Okay? Which really, using the grid method, sets it up rather nicely, right? Look at this. We had 45 fake tattoos. We got the number of bags as greatest common factor, and 5 is the answer. It's kind of that factor buddy with the 9, right? So if you go in further and label what each of these numbers means, then you can get to how many. You know, each bag will have 2 kazoos, 4 stickers, right? So the grid method really sets this up well. We skipped over the top and we'll go back to it now. Not so much with the greatest common factor, but just factors in general. It says your grade is 48 students. List all possible ways you could divide your grade into equally sized groups using all of the students. Give me one example of how you could divide 48 students into groups. And so all students are included. Those that like the listing method, this is kind of for you. What's a factor pair of 48? Yeah, sure. You could do 6 groups with 8 kids, right? 6 groups, 8 kids, 6 times 8 is 48. What? You could also switch that around. You could do 8 groups with 6 kids, because 8 times 6 is 48. Okay? So you can do the rest of them, but I want all the possible ways that you could divide a group of 48 kids or a class of 48 kids into groups. Yes? There are 10, I believe. All. Doesn't say almost all. Doesn't say about all. It says all. Okay? Then you've got some more down the page here. You are putting coins into identical piles. There are 21 quarters, 14 dimes, and 35 pennies. What is the greatest number of identical piles you can make? How much money is in each pile? You are making bouquets of flowers using 12 roses, 20 carnations, and 45 daisies. Explain why you are unable to make identical bouquets using all the flowers. Why can't you do it? Then provide one possible scenario for how many bouquets you could make, along with how many of each flower will be left over. So you'll find you can't make identical bouquets using all the flowers. Why is that? But what could you do? With the flowers you have, what could you do? Got it? And then at the bottom, write a set of 2 numbers with a GCF of 12, and then write a set of 3 numbers with a GCF of 11. Okay? Questions, comments, concerns, complaints, compliments, congratulations, or criticisms on this, sir?
Which ones are homework?
All of it.
This.
Not almost all, not about all,
All this.
all. Yes. And whatever you didn't finish on the page before also. John,
Congratulations.
for?
Something.
Thank you. Cade?
What does it mean by 3 sets?
So it says write a set of 3 numbers. A set of 3 numbers would be like 3, 8, and 10. That's not the answer because they don't have a GCF of 11, but that is a set of 3 numbers. Anything else? Yes. You've got about 5 or so minutes, 6 minutes to work on homework now. Folks, hey, you're isolating. Yes, Wyatt.
I did this like over the summer too.
Great. You can do it again. Should be easy. Okay, homework for tomorrow. That, folks, is how you math.